So let's start the mechanics. The mechanics is where you do the mathematics. Okay. So it's going to be shape, center, spread. Okay. You said we are going to use a normal model right here, so we are going to draw a normal model. Okay, that's the shape. The center, you said it's at 90%. So that would be the mu, meaning the average here is going to be 0.90. Okay, and then the spread of this sampling distribution is going to be, check your formula, it's the square root of PQ over N. Okay, so let's just substitute values. It's going to be the square root of P is 0.9, Q is 0.1, and then divided by the sample size, which is 400. And so let's compute that. Okay, so we got 0.9 times 0.1, and then we got 400 here. Enter. Okay, we got 0.15 or 0.15. Oops, that's wrong. Let me erase it. Or 0.015. Okay, so we got shape, center, and then spread. The next step is the data value. Okay, and our data value is the P hat. And if you notice, we are not given the percent here. We have to compute it. It's 376 out of 400. So we got 376 over 400, or what is that? 376 divided by 400. And that's 0.94 or 0.94. Okay, and after that we get our z-scores, so we can compute the z-scores now. And the z-score is going to be, again, data value 0.94 minus the mean. The mean is 0.9, and then divided by the standard deviation, which is 0.015, or what is this? 0.94 0.94 minus 0.90 divided by 0.015. Okay, enter, and so the z-score is 2.66667 or 2.667 right there. And so after we get the z-score, let's draw it. 2.667. This one is saying, our null is saying higher, so it's going to be on the right side. Okay, so probably about here. Okay, and so we want to know what is the area here. Okay, and so the area there is going to be the probability that the z, see, all the z's in here is going to be to the right of this one, 2.667. So the z is higher than 2.667, and so we compute that by using the norm CDF. So that would be norm CDF, say from here, which is 2.667, up to, see, this one goes to positive infinity, and then we got 0 and then 1. Or, and we compute that, norm CDF, menu, stat, distribution, and then we get norm CDF. Again, it's from 2.667 up to, let's just put a big number right here. Okay, and we hit OK, and so that norm CDF is going to be 0.0038. Okay, so we go right here, 0.0038. Okay, so that's like 0.3%. That's very small. Okay, and we would say right here, okay, and you have to pay attention how I write the conclusion, okay, because this is standard. This is how we say our conclusion, with a small p-value, probability value, equal to 0.0038. See, this is very small. This is very unusual. If you remember before, if it's less than 5%, meaning 0.05, if it's less than this one, it's going to be unusual. And so this one is very unusual. And so if something unusual has happened, then probably because our assumption is wrong, or it has already changed. It's, in this case, it's not 90% anymore. Okay, and so we say, with a small p-value equal to 0.0038, we reject the null okay. There is strong evidence that the proportion of homes with at least one smoke detector in the city is higher than 90%. There you go.